So, welcome back to another episode of the Python People podcast, the home for global technology leaders to share insights with the tech community. And a very warm welcome to this week's guest, Enrique Munoz de Cote, who is a data leader and I think serial entrepreneur is probably the best description we can use for you, Enrique. And yeah, I guess to frame the episode today, Enrique, you've got a really interesting story because obviously you've come from a very impressive academic and research background and then gone on to achieve some really exciting things in sort of commercial world with ventures that you've been involved with and various startups and tech businesses as well. So I think you've got a very unique perspective and hopefully a lot of value to share on both sides of those coins. So it'd be great to, I guess, find out a little bit more about you and invite you to give us a bit about your background and your career bio to date, if you'd be so kind.
Amazing. Well, thanks a lot for the invitation first.
You're welcome.
It's Friday and it's sunny.
It is
Nothing
indeed.
can go wrong, right?
Exactly that, yeah. It is Friday the 13th though. I only just realised that earlier on. But apart from that, I won't worry about it.
All right, amazing. Well, a little bit about my background. So I think my path really starts with my undergrad degree. I was in biomedical sciences, and that's where I mostly fell in love with the exact disciplines like maths and physics and biology. I did a PhD in machine learning. That was quite fun. Actually, this was before machine learning was fancy.
Before machine learning was machine learning.
Pardon?
Before machine learning was machine learning.
Yeah, exactly. Everybody was like, "What is that AI thing? Like, how do I do that?" Like, yeah, nobody knew about that. So, I did a postdoc in Southampton in multi-agent systems. That was a fantastic time. Actually, it was a big project that I was involved doing autonomous agents. That was the kind of like the first application that I started really where I really understood the power of machine learning in the future, because this was. First of all, this was a collaboration between the host, the University of Southampton, and Oxford, and Imperial College, and Bristol, and some enterprise like Bay Systems. And this was about understanding how autonomous agents in an open environment could end up doing things like making their own decisions. Take care of problems like how would they coordinate. Some of them might even be competing if this is a really open multi-agent system. How would you think about optimizing at a system level if they're set up to make some kind of task? Very hard problems. Those problems are still like open questions.
Yeah.
But back then, it was like really the first time that we actually started thinking about those problems. So I've been an academic in machine learning after that. So I was faculty. I am faculty still. I've graduated, I don't know, like 13 or 14 master's students and like 6 or 7 PhD students. I don't teach anymore right now on graduate level. Then I was an early employee at Second Mind. This was a company, still is a company based in Cambridge, the UK. Being an early employee there, my main focus was basically to do great breakthroughs in scientific advances in machine learning. The disadvantage there was we were a tiny team compared to the competition. Competition being the biggest suspects, Google and Facebook and the likes. However, we did differentiate ourselves quite interestingly. Our take on machine learning was and has always been try to achieve the same kind of performance with a lot less data, which we didn't have our hands on. So, and it turns out that that's possible, and that's actually one of the biggest things and concerns nowadays, that well, what if you're not a Google that cannot don't have that kind of computer power and data access to data? What can you do about that? Does that mean that actually you cannot use machine learning? And that's not true at all. There are some techniques as powerful as deep learning or the kind of classic approaches that these big companies uses that are probably a better fit to your problem, usually, actually. So we did great. I moved on from that due to my curiosity, basically, to understand how to apply machine learning to change the world. Really, I really was interested into making machine learning, turning it into from a cover page fancy acronym to really something that is transformational for an industry. So I was very interested in understanding how in different industries might use machine learning, and I've been on that path ever since, really. I started a deep tech machine learning focused consultancy business to understand problems around on that path. And I've served many verticals, including biotech and fintech, insurance, technology, healthcare, and even government. I helped the cabinet office understand, for example, 70 petabytes of digitized documents, which is kind of like one of the first real big data problems that I see outside of the biggest suspects again, which was a fantastic problem to work on, definitely. Well, the kind of technologies that I would apply for solving these problems is like, well, my specialty, reinforcement learning, but also Gaussian process, natural language processing, computer vision. I then open up a company, Gekomatics, this an AI computer vision startup funded to solve the scarcity of high quality recent geographic information. That's a mouthful, but it means that we were really interested in redesigning how outdoor mobile mapping is done. We use 360 cameras that you can mount on any vehicle, and after getting all the information, all the data, then our deep learning algorithms will recognize objects and put them on the map. Basically, that's in a nutshell what we're doing. And then I joined forces with a friend and colleague of mine, and still are on that path, to kind of merge my agency, my deep tech agency, with his. His agency was about growth, and it ends up being a data-driven approach to growing startups. And that's kind of like my path into entrepreneurship and the mix between science and tech, really.
Awesome. All right, thanks. That's really really interesting to hear your sort of foundations, and given that you've come from that kind of numerate sort of mathematical background, was it always a logical choice for you to go into the data science and machine learning world in particular? What sort of drew you to that versus maybe going more into software engineering as an example? What was it about data science and machine learning that appealed to you?
Right. Well, I think the idea of getting into technology overall, it started really a long time ago. I think I knew that I was going into that path since I stayed for a year with my grannies in the States. I was 12 years old back then, and my grandparents, they bought me my first computer. And however, being grannies, they knew nothing about that. So they just told me, like, this is this big machine that promises to do a bunch of things. Off you go. Like, do you want to play a game? You need to understand how to install it and how to make that work. And then all sorts of problems started appearing. Like, I didn't have enough RAM memory, and I was 12 years old. Like, and I was going with my machine to the shop and trying to, like, with real geeks, trying to find out what the problem was, how to install stuff. And yeah, that was my fascination with making machines work. And yeah, that's what got me into machine learning, because that's actually the kind of formal training on how to make machines make decisions.
Yeah, yeah, absolutely. I can understand that, and I think it's interesting because I've gone in my background of 15 years of tech recruitment. I've seen probably first 10 years of my career actually was focused more so on the software engineering side, and then since starting True North and us focusing pretty extensively on the data science side, yeah, I've kind of seen both of those markets and sort of how they interplay. And of course, there's a lot of similarity and a lot of overlap, absolutely. But I think one of the biggest differentiators that I've seen, and one of the things that comes across quite regularly to me when I'm speaking to candidates, is the passion for, you know, how machine learning can, you know, different approaches to, you know, really big, messy, open-ended problems, but how they can genuinely solve real world problems, you know, and either problems for businesses or problems for, you know, other causes. But is that link between, you know, when you're coding an application, okay, it's great, sometimes it's, you know, fine to see the website built at the end of it, you know, that's fantastic. But actually in the data science world, I think, you know, you can kind of go one step further and actually really see how what you're doing is having a genuine impact in the real world. And I think that's why I was quite keen to understand from your point of view, sort of the, you know, the differences between research and academia, and how data science is applied there, and also how you see, you know, data science in the commercial real world applied, you know, ML setting. You know, how do you kind of see those two interplaying? Because I guess that a lot. I think from data scientists around, you know, is there a tangible value in furthering my education? You know, let's say somebody's got to sort of a master's degree and they're thinking, right, should I go and do a PhD or not? And, you know, I guess my answer to that is always, it kind of depends what you want to do ultimately, but really, you know, what's gonna provide you with the most fulfillment, you know, and because I think both areas will develop different skills, I suppose. But how do you sort of see those two interplaying between academia, research and data science, and real world applied, you know, data science?
Great question. I think there's no like one silver bullet answer to these, really. I see it as a double-edged sword, really. When you over specialize, then definitely you will end up in a situation where you're probably a world leader in one area, but you're too into it that it's really hard to abstract out. On the other side, when I see that all the time with my employees with a master's degree trying to do like groundbreaking stuff, that they just don't have the tools to get to the next level. So, long story short, I think as much as you can learn, machine learning is not an easy topic. It's not let's use something that is outsourced and let's download it from GitHub and start something. You can get as far as like that 80%, but the extra 20%, that's going to take you a lot more effort. And you will need a degree, like a PhD for that, and probably more, way beyond that, to get that extra 20%. And sadly, machine learning is like that. Like everybody can get to that 80%. Chat GPT right now is at that. Like it's great for a lot of things, but when you really want to use it and apply it for something serious, that's when it breaks down, and you're not going to be able to use it most probably. And that happens with all, like across the board, really, in machine learning. So you can get something very fast to get to that 80%, but when you really try to apply it to the real world, that companies and industries, they're gonna try to get it to over 90, 95, 99% if you're in healthcare of accuracy. And then that's where the classic stuff don't stop working, and you really don't know what you're doing if you don't have a proper degree about that.
Yeah, that's really great. I've never kind of heard that description of how the two interface, but yeah, I can sort of fully understand that. So do you feel that it's valuable to do a PhD in a domain that actually you may end up not working in? Let's say you go and do a PhD which is focused on solving a particular problem within, you know, image classification and recognition within health tech space, but then actually you end up going into a different area. Do you still feel there's a value in the skills and the kind of research that you do within a PhD, which sort of just makes you a more complete data scientist, even if you're not necessarily in that particular niche?
Let's see if I understood your question. So what you're saying is, does it really make sense to like specialize on something very specific in doing a PhD in something very specific in machine learning, and what kind of areas would be most promising to specialize on? Yeah.
Yeah, it's kind of like, if you're going to do a PhD and you're going to sort of do research to solve a particular problem, and let's say it's very niche within the health tech space, which is obviously an area that data science is adding a huge amount of value at the moment, and it's fantastic. It would make sense, like you said, to get that extra 20% that somebody's really specialised in that particular niche, really understand the inner workings to get that level of accuracy, like you mentioned. Even if somebody ends up doing a PhD in that particular area, but then maybe further down the line they sort of want to transition into a different area of different industry, different domain, area of data science altogether. Do you still feel there's a value that's gained through the process of going through the PhD and the kind of research that you would do there? And do you feel that's actually, does it make you a more complete data scientist that you could then extrapolate that out to other domains, other challenges, other problems?
Right. Well, it might not work. So, long story short, I absolutely think that that's the case. You will be able to. What you're really getting from a PhD is just you specializing on something, definitely, but you're also getting into that mindset of problem solving in a very rigorous way, with the right kind of tools. So those tools are applicable across the board, really. So I specialize on decision making, which is a type of machine learning called reinforcement learning. However, my previous company was in computer vision, and I knew little about that when I was doing my PhD, and even when I did my postdoc. But that didn't prevent me to actually do some very interesting advances in computer vision when I opened up my company. And the way that I did that, definitely there's a learning curve, but it's a much lighter learning curve than if you want to start that with just a master's degree. So yes, I think it does help, and it also, I think I mean, if you're specializing on doing a PhD on something super particular, then probably there's less chances that you're going to be able to transfer some of that knowledge to something else. But there are so many very interesting unsolved problems right now on machine learning that are worth many PhDs. That definitely there's very good chances that you're going to find something that you're going to find useful, regardless if it's exactly the thing that you specialized on.
Yes, I can definitely understand that, and I think to that point, that's one of the things. Again, I'm really passionate about with the domain of data science. Is actually there's some, you almost, once you have that foundation, you have that ability to approach certain problems and understand the best fit for the particular problem that you're dealing with. It's kind of a really exciting world then, because it's up to you really what problem you want to solve, isn't it? And kind of how universally applicable data science techniques and strategies can be to really solving whatever kind of problem you want to solve. And I think that's one of the greatest I think I'm really optimistic about the data science career as a
right, yes.
is because you can actually end up working on some really disparate problem over here one year, and then maybe another problem over there, but it sort of keeps it really interesting for the individual as well, because obviously they're constantly learning about different domains and different areas as well. So yeah, that's I think that's a really good point.
No, but thinking about the other side of the sword, over specializing definitely has its problems. So you end up spending 4 years in something very, very particular that at some point you're not going to see, like, why did you even get started into that path? So it's not for everyone, absolutely. And probably sticking with the master's degree, it's depending on your career path, really. Because if you're into entrepreneurship and you want to become something like a CEO kind of thing, then you probably don't need a PhD necessarily. You're probably like well off understanding at not even at the superficial level. Like I've seen like fantastic master degree problem solvers that are up to par with anybody with a PhD. But I mean, it depends really on your career path. So a master's degree is, I think it would be the bare minimum to get into a technical field like machine learning, but you don't necessarily need a PhD at all, by all means.
Cool, interesting, and I guess on the other side of that, the kind of talking about specialization, you mentioned earlier, a lot of companies often are put off the idea of machine learning or sort of pursuing something in machine learning because they think they haven't got the computing power of Google or the kind of maturity or the size of the data sets that they would need to get any kind of value out of machine learning. But would you say, there's a particular trigger point for a company where they could actually get some really valuable machine learning initiatives underway, either a size of data set maybe they have access to or a maturity of their data processes, or what would you say actually is the kind of trigger point for you that you would say actually there is a real use case here that data science and machine learning can really add a lot of value? What does that look like to you?
There are two industries or two technologies really that are ready to be deployed in industry. One is computer vision, the other is natural language understanding or natural language processing, it's usually called. And those two things are definitely technologies that are quite ready to be deployed in many different problems, from healthcare, for example, to have your kind of like your first triage point of contact with just to really understand what kind of problem you have, kind of like a first contact to your GP, to things like the company that I formed previously, which is understanding your surroundings through computer vision. Those kind of things definitely that are not life-threatening definitely can be tackled with machine learning nowadays. Autonomous driving is another area where all of these things come together, really. So absolutely, there are fields ready for machine learning. There are others a little bit more exotic, like we still don't know exactly what type of what data set size do you need, how clean do you need it, what type of techniques work best for different things. So it's a problem to be discovered, really. And however, that's exactly what I'm specializing right now. Like the way you make a company from a prototype into a real thing into a real machine that produces value for customers and hence make a company grow is by trial and error, by having a fantastic experimental framework where you go from prototype into application as fast as possible and as accurate as possible. So you break stuff along the path. That's great for innovation. You don't have many rules, but you also need a framework on how to deal with experimentation. What happens if it's not working? What kind of results are you hoping for? What methods are you using for trying things out? So a simple example is, for example, on marketing. Marketing, it's like there's so much data out there to be able to be injected into an algorithm and make sense of what works and what doesn't, optimize basically your marketing campaigns. So that's a problem that definitely nowadays most of the serious companies in marketing are using some sort of algorithms or some sort of a data-driven decision making. However, is it working across the board? No, I think it's early days. Some of them that have these experimental framework already kind of carved out, then definitely those are the ones that are making a difference. But yeah, what experimental method? How do you use it? That's something that I'm trying to figure out right now as we speak, actually.
Okay, interesting. Yeah, because you mentioned now you're also applying this approach to how you can help data scale ups in the next phase. So talk to us a little bit about that then, and this kind of exciting venture you're going on now.
Right. Okay. So yes, now that I joined with another agency doing specialized on growth, then first of all, I wanted to learn how to apply these very successful concepts of growth with a data-driven approach, and that's what makes me very curious now. Like, how do we, based on new evidence, like the experimental framework, you make better decisions that drives to growth, meaning more clients, more stickiness, less churn, things like that. And together with that, definitely there's a marketing uh, uh, there's a marketing side of it that tries to get more customers, more acquisition, but there's more internal things that also you want to use as experimentation. So if you're into like computer vision for understanding or diagnosing something in healthcare, some kind of condition, then probably you don't have necessarily the right now the solution to your problem, but you might have some very interesting educated guesses of where you think the technology, what type of algorithms, what type of data is needed to get to that solution, and then it's just a matter of trial and error. I've done that with some of my clients, for example, in insurance technology, where the problem was let's try to optimize from a client that submits a claim to getting paid. That's a problem that every insurance company actually, they all want to pay out really, but there's so much handholding that it ends up being like a very daunting process of like 2-3 weeks until you actually get paid.
Mm.
And minimizing that time to getting paid or getting to a resolution, it's really not straightforward. There's conversions from something that probably it starts with a manual form filled out manually to something that is like, yes, there's enough evidence. There's an insurance policy on the other side that you need to check against. Is this covered? This is not. What kind of event was it? Is there computer vision involved? Like, is there any kind of evidence to sustain that? Like, what really happened in that event? What were the sequence of events, and that it ends up being a very hard decision making problem. But definitely, is there a chance the machine learning can intervene there and optimize that? Absolutely, yes. Maybe not everything one go, so you end up trying to you choose your battles, like you choose what subset of things a machine might be able to help. And really, for me, machine learning, it's not an alternative to decision making, as in you don't use machines instead of humans. It's more like a decision support system, really, where you use algorithms, you use machines to make better decisions.
Mm-hmm.
Humans, at the end of the day, is making these decisions, but they have a lot better tools at their disposal to really make sense of what's going on.
Yeah,
It's
yeah,
really augmenting the decision making power of a human, and
interesting.
that's very powerful, really.
Yeah, yeah, absolutely. And I suppose when it comes to that concept of automation versus human input, what's your approach as a entrepreneur, having founded and built data functions from scratch and scaled data functions? What's your approach and kind of what systems do you take to to building data science teams? Sort of what do you say there's kind of an optimal way of doing things from? And I guess that question's relatively loaded because it's probably a very different answer sort of pre and post pandemic now. We're kind of living in a bit of a different world. But yeah, what's your take on kind of human input, a team, versus actually being able to do a lot through just
Right.
very smart systems?
That's massive, actually. That's probably one of the biggest problems to success and for growth and scaling? That's probably one of the first questions that if you're fundraising, VC fundraising, that's going to be one of the first questions asked. How do you grow a team? A fantastic world-class team. And the way that I approach this is really to realize that this is not a transactional operation. Like, you're not hiring people. It's not a pay and receive work kind of transaction thing. It's a lot more of a purpose and meaning sort of thing. There's an interchange of knowledge and skills and time and money involved, but all targeted to purpose and meaning. So that's the number one thing that I would that I like realizing, that people want to be involved in something that has purpose, and it's not just for a paycheck. Not at all, actually. I also like to be a mentor to all of my employees, and that helps in being sort of like a career builder thing. Coming from academia, then definitely I know and I understand growth paths, and I really like my teams growing, even at a higher pace than me. So at some point and that's why I hire people. Really, it's not for me to call the shots and tell them what to do. It's the other way around. They should be telling me what to do. And that's what I like about my employees. They don't need to start there, but eventually they will become the experts, to the point that I need to ask them questions and they need to tell me what to do next. And that becomes very interesting.
Yeah.
Then I like to focus on their goals as well. So that's something that is probably not all the time understood. Like, you really need to understand what they care for, what they're optimizing for, to understand if they make a good fit with your team. Because if you don't do that, then there's probably going to be some frustration with that new employee or with the rest of the team. So check for alignment. Check if how good of a fit that new person is with the rest of the team. And that's pretty much matchmaking, and that's something that I really care about. Like, personality between teammates, is that going to work or not?
Yeah, I think there's some really great points in there, and actually interesting hearing you speak. Actually, how I can see a huge amount of overlap between the practices you're applying there to building data science teams, and actually similarly how I feel about building recruitment teams as well. So when we're hiring internally. And to your point about purpose and meaning, I couldn't agree more. From a data science perspective, I think it's really important. That's one of the things I probably advise clients when they're interviewing candidates. Kind of first and foremost is like, really, if it's assumed that somebody has all the techniques and understanding, able to do the statistical modelling and all that kind of thing, that's great. But fundamentally, do they care about the problems that they're solving? I think that's the most important thing. Is there that kind of purpose and that kind of meaning that's there? And it's the same within recruitment as well. I mean, I guess there's lots of different recruitment companies out there, but all doing the job in a slightly different way. But the most important thing to me is that we've got people on board that buy into the mission. What we're looking to do. Our mission is fundamentally to make work a happier place for people. That's kind of what we place people into jobs, but we really want people that look at the world through that lens. So I think giving that purpose and meaning to people is absolutely key. I think it's sort of thing that helps drive people forward when we all have bad days and we get knocked off the horse. Definitely it's the thing that pulls me, gets me out of bed every day, ready to rock and roll. And
I tend to look at this as a sort of like an evolution sort of perspective, like a system evolution thing, like where there's incentives at the system level. A company needs to achieve some goals. That's some sort of incentives, and there's personal incentives as well, and there's teams incentives, and there's your manager incentives, and there's all sort of incentives. When you align them well, then definitely there's a very good chance that everybody's going to be happy, everybody pulling the same direction, and things just progressing, which is what you want to see as in a company, really.
Absolutely, yeah. And I really like your point as well about the kind of acting as the mentor to the employee, but actually at some point, you kind of, it's the only way to sensibly scale any business, that at some point the whole is greater than the sum of its parts, and people do sort of surpass you probably in certain areas of expertise, or they do bring something else to the table rather than you sort of necessarily needing to be there and micromanage people. And I think that's a really healthy approach, but I can imagine it's a paradigm that doesn't necessarily play out in a lot of companies, where probably a lot of companies with poorer culture still feel that it's the manager who's the manager and they're in charge and they're the authority point, and it's everyone has to do what I say. And again, I certainly see that in recruitment a lot. Companies that have poorer cultures, very kind of micromanagement, versus one of our core values is innovation, right? I mean, I've been doing a job 15 years, but if somebody walks through the door tomorrow with a month's experience and they think of a better way of doing the job than me, why would I say no, it's my way or the highway? You'd obviously listen to that person and and sort of encourage those ideas. So I think that's another really good point. So yeah, you kind of clearly you've got a very interesting and varied background, and it's a question I always like to ask entrepreneurs that have gone and achieved great things. What would you say is the biggest challenge you think you faced in your career, and how did you overcome them?
Well, it's hard to choose one, actually, but probably one of the hard choices I needed to make was very early on in my undergrad degree. We're so young back in that age that making a good choice about your career path, it's a very hard problem, a very hard thing to solve for at that age. So, and I ended up in the wrong path initially, and it took me quite some effort to move paths early on when I was already quite advanced at my undergrad, to just say, like, really, this is like, I was on a management path at the beginning, and halfway through I found out that actually didn't make any sense. I was not happy, and that was not fulfilling at all. So I needed to move, really. But making that choice, that hard choice, that was kind of bold, and it paid off. Absolutely. That changed my life completely. And when I moved, actually, that I was twice as incentivized as the rest. So that actually ended up being a fantastic motivator that still drives me nowadays. So that's good. It stuck with me. So that's one of the things that was quite hard. One of the biggest challenges, probably initially, to make those kind of hard choices. More on the on the latest path on entrepreneurship, probably coming with a technical background means that, especially with a scientific background, we're trained to solve problems, to discover things, really, to solve things that haven't been discovered yet, without necessarily understanding or caring too much about the application in an industrial level. There's an application, obviously, in universal understanding that's of greatest value, but maybe not with the greatest of applications in industry nowadays. Maybe it's a futuristic thing. And it ends up that some of the times with that kind of a scientific mindset, you end up having a bunch of fantastic solutions in search of a problem. And that is a very hard problem to face, actually. So one of the biggest challenges that I faced when I was an early employee was to turn solutions into products. So I had fantastic solutions, breakthrough solutions, really, lots of IP. And how do we turn those IPs into a tangible thing? And my honest answer is, I wouldn't like to be in those shoes again. I don't think that's good for industry. I think it should come the other way around. You should try to find a problem, a real problem, a pressing problem that in industry, and then find a solution for that, like the best fit solution for that, not just like a fantastic solution for looking for a problem.
Yeah, that's actually really very good point, and it's reminded me of this program that we're watching at the moment. Actually, I don't know if you've seen it on Disney, called The Dropout, and it's a story about Theranos and Elizabeth Holmes and that whole business, and that's a great example of what you've just said there of a company that's focused on, we've got to build this tech, we've got to build the IP, and then we'll work out how it's going to be of value to humanity, rather than looking at the bigger problem, bigger picture first, and then sort of extrapolating that back into, okay, well, what's the best way we can build tech to do that? And I think that's fundamentally what got them in the hot water, and ultimately why they got prosecuted, just because they were claiming they had this tech that they didn't have, and then sort of going about the thing all wrong. So yeah, I think that's a very very good point indeed. Okay, fantastic. Well, I think it's been an absolutely awesome chat, Enrique. Really enjoyed speaking with you, and I like to end all podcasts in exactly the same way. As a man as wise as you, I'm sure you've probably received lots of advice over your career, but I always like to ask, what's your one favourite piece of advice that you'd like to share with the rest of humankind? Yes, what's the best piece of advice you've received?
All right. Well, probably the one that I like the most is don't let fears of what other things of you stand in the way. Basically, you want to, if you have, you want to stand for what you care for. So that's probably one of the people. If you have something and you want to stand by it, that's probably one of the biggest things that I've learned in the past, to just stand by your ideas.
Yeah, fantastic. I think you're right. People often fail in their own mind before they get started, don't they? Because of the fears of what may be. But yeah, having confidence and faith in your own volitions is something I think we could all benefit from. Absolutely. Superb. Well, look, really enjoyed speaking with you. Thank you very much for your time. Yeah, I wish you all the very best with your venture. I'm sure very exciting things to come with your VC incubator of data and tech scale up. So yeah, I look forward to watching your progress closely, and I'm sure we'll speak again very soon.
Yeah, fantastic. The latest thing is still on stealth. So if you invite me later on, then definitely I can tell you more about that.
I will do, absolutely, rest assured.
Fantastic.
I'll be in touch. All right, good to see you, and
Thank you very much.
yeah, thanks again.
All right, cheers. Bye.
No.